Hello friends, may the 4th be with you. Welcome to this preview of my new course React Roots, which teaches the basics of building modern single-page web applications with React and TypeScript. If you go to reactroots.com, you can learn more, and specifically if you click on the section What Will I Learn in this course, you can see all of the lessons from the course. And if you click on Lesson 3, that's what today's preview comes from. So this preview covers these two learning objectives: use Vite to generate React applications, and explain the purpose of each file in a generated React app. I hope you enjoy this preview. If you do, definitely check out reactroots.com to learn more. Here it is. All right, let's write some React code. So for this, we're going to use Vite. Vite is next generation front-end tooling. So this is a build tool. It's similar to like Webpack, if you've heard of Webpack. It's similar to Parcel. Under the hood, it uses this thing called Rollup, and it also uses this thing called ESBuild. But essentially, when we write React code that looks like this, it has to be turned into actual JavaScript. And so Vite has a plugin that can do that for us. It handles all of the details of making sure we have the right like React dependencies and everything else. And first of all, it provides a really fast development experience. So when we're building apps with Vite, it's using ESBuild. And essentially that makes working with in development really fast because it doesn't have to transpile everything completely. It basically transpiles things just enough so that they work in the web browser. And then when you do a production build, it actually uses Rollup, which makes sure that it works across browsers and does minifying and everything else. So we're going to be using Vite. If you want to compare it to something, you can compare it to Webpack or Parcel. Vite is the new hotness, and it's kind of here to stay. Solid.js uses Vite, Svelte uses Vite, Astro uses Vite, various other things use Vite. Everything is using Vite. Essentially, it's become like the tool that everyone wants to use, and it's zero config as well. So yeah, and so Create React App is what we used to use, and there are just a lot of issues with it. It's old, and the mechanism for how it managed things was very cumbersome. So Create React App under the hood used Webpack. But by default, it hid that configuration away from you. And if you wanted to modify it or like add new build settings, you would have to eject. And that was potentially cumbersome because now you have a big config to maintain. You didn't necessarily have to do that because there is a tool that would let you modify the config in your Create React App without actually ejecting, but it was a third-party tool. It wasn't supported on main, and then there are other various issues as well. Yeah, there's a lot of drama around it. I'm not going to talk about it. All I'm going to say is we're going to use Vite. It is the if you're building a single-page application like a completely front-end React app, Vite is the way to go. I talked about this the past 2 days, but we're not going to be building server-side rendered apps. For that, you potentially would use something like Next.js, and Next.js does not use Vite. Next.js uses, I think it uses Speedy Web Compiler, this thing. All of that to say, you don't have to worry about it because it handles everything for you. It is good to know what these tools are and like the fact that they're happening under the hood, but let me show you how easy this actually is. All right, so if you go to Vite, you click on Get Started. They have a few different templates that you can use. We specifically are going to use the React and TypeScript template. And what we can do is just run this command. Yeah, so there are a lot of issues with Create React App. I mean, if you search Twitter, if you search YouTube, you can find people talking about it and giving a rundown. I'm of the opinion I just use what works. So, I mean, I used Create React App for a long time, especially like if I didn't need to modify the config, and it was fine. These days, I use Vite for everything. All right, let's go. So in this directory, I'm going to run this command. Now, technically, you can pass in an argument and just say, hey, I want to use the React TS template, but let me show you. If you do it without that, you're going to get some options. So I'm going to run this, give it a project name. Let's call this Intro to React. It's going to create a folder called Intro to React, and then we can choose our framework. So in our case, we're going to use React, but you can see that they have templates for other front-end frameworks or just vanilla JavaScript as well. So we're going to choose React, and we're going to choose React with TypeScript. Now, you could choose TypeScript with SWC, so that's that Speedy Web Compiler thing, but in my experience, there aren't as many supported plugins for it, because if you choose this one, the plain TypeScript one, it's using Rollup, and there are a ton of Rollup plugins and community packages you can use with it. So we're going to choose this one, and now it created a folder. So it created a folder called Intro to React. If we go into Intro to React, so in this folder, we have our app that was generated with Vite. I can install dependencies. because you can see like they give us a package JSON, they give us a TS config, so they basically give us everything out of the box. And then I can install dependencies, start it up with the dev command. So if I do npm run dev, that starts it up. I open it in my browser, boom, I've got a React and TypeScript app that's running with Vite. Okay, so the next step is we're going to talk about what actually got generated here and talk about all of these files. But yeah, Vite is cool. You can use it for a lot of different things. We're specifically just going to be using the React TypeScript template. And then later on, as we build more complex applications, we might have to dig into how do we handle static assets or various types of things that we want to load in. But for the most part, we can kind of just use the setup as is. Let's talk about all the files in this generated app and what do they do and why do we need them, etc. So when you generate a Vite app with React and TypeScript, it's going to give you this. Like I said, it has a TS config. So this has some sensible defaults. You can see that it has a target, but you can see we don't even have to touch this. Like we talked about yesterday what some of these properties do and why we would need this TS config, but we can just use the defaults unless we're doing some custom TypeScript stuff that isn't supported by default. You'll see that there are two TypeScript files. This one is for React, for our front end code. You can see that it's referencing DOM iterable. That means we're going to be able to do front-end type things in our TypeScript code there. This other TypeScript config has called .node. This is for the build process. So on day one, we talked about how we use node.js to build our front-end code. So when we are running our app locally, the actual code under the hood that uses TypeScript is using this config. So again, you don't have to modify or touch either of these, but this one is being used by the build process. This one is being used for the code that's running inside of the web browser. If you look at the Vite config, this is literally all we need. So they have this plugin called React. We add the plugin, and now we can start working with React code. There are various other plugins in the ecosystem, and then there's a way to modify like the rollup config and any of the other options if you need to. But yeah, you can check out this site if you want to modify more, but for the most part, that's all we need. And then we can look at the package.json. So it gives us some scripts by default. When we run npm run dev, it's running Vite. When we run build, it's going to run the TypeScript compiler. Remember, we talked about this yesterday. And then after running the TypeScript compiler, it runs the build to take all of our front-end assets and turn them into as few files as possible and as few bundles as possible. And then preview is a way of previewing the built version before we deploy it. You see that it has a dependency on React and React DOM, and then it has a dependency on their types as well. So yesterday we talked about how some libraries don't have the types built in. So if we're using them with TypeScript, then we're going to need these extra type libraries. We have the React plugin, TypeScript itself to give us the TypeScript compiler, and then Vite, which is used to build. So overall, a pretty simple setup, but it gives us all of our dependencies so we can get going from there. I didn't talk about the package lock when we were talking about Node and NPM on day one, but the package lock essentially allows these NPM installs to be consistent across projects because you can see here that we have various versions. And this little sign right here means we'll take anything 8.2.0 or above. So it's possible that it actually installed 8.2.1 or 8.2.2. And we potentially want to know that, so all of that information gets into the package lock. So when someone else does an npm install, they get the exact version of it. But you don't have to worry about that. Now we have our entry point. So you can see it's just a plain old HTML file. It's got a title, and then it has this one element right here. So our entire React app is going to live on that one element with div ID root. And then you're seeing something interesting here on line 11. So first of all, script type module. We talked about this on day one. Essentially, this allows us to use modules in the web browser. But you'll notice we're actually linking a TSX file. And browsers don't understand TSX files. So this is actually some of the magic of Vite and ES build. So when we're running in development, we link to our actual source code, but behind the scenes, whenever it sees that, it's like, oh, well, I need to transpile that into JavaScript. And then if other files are linked and they're TypeScript or they're or TSX, then it's like, oh, I need to transpile those as well. So on the surface pretty simple, but when we build our app, we can't do this, right? Because by default, web browsers don't support TypeScript. They only support JavaScript, HTML, and CSS. Okay, so that's the HTML. That's our entry point. We have our public folder, which links the favicon that you can see right here. And then we have our source directory, which is where all of our React code is going to go. Now, you can see here we're linking source main.tsx. So if we look in source and we look at main.tsx, this is the thing that gets loaded in. And you can see we're bringing in React DOM, and then we're bringing in our app component and some CSS. Here you can see where it actually gets rendered. So essentially all of our application code is defined in that app component, and then it gets rendered out right here. And this is TSX. Or JSX if you're in JavaScript. But the fact that we can have these HTML elements like right in the file, this is TSX. We're going to talk about the specifics of TSX in a bit. For now, just think of it as HTML mixed with your JavaScript. And then we're also seeing some type assertions here, right? So it's grabbing that root element and then saying this is going to be an HTML element. And if you remember yesterday when we were talking about TypeScript, we can use type assertions when we know that something is going to be of a certain type, right? Because if I don't have this type assertion, it says it's possible that it's null, right? Because when you select an element in the DOM, it might not exist. But we're like, hey, we know it exists because we defined it. There's literally an element right here with div ID root. So I can just say, hey, I know it's going to be an HTML element. It's not going to be null. I think the other way you could do this with TypeScript is if you do an exclamation mark, you basically tell it, that thing's not going to be null. It will exist. But you can see we're basically rendering our entire app to that one element. You typically won't have to touch this file unless we're changing like the top level rendered components. But this is basically the entry point. And from there, we can start looking at each of these files. So first of all, let's look at app. So in here, we can follow to app.tsx. And we see our app component. You can see that it's bringing in some state. It's bringing in some images and some CSS. It's creating some state, which we'll talk about. And then we have our actual app component. So we've got a div with 2 anchor tags. We've got that header. We've got a div with a button that we can click on. And so that is what we're seeing right here. So we see those 2 images. We see the header. And then if I click this button, I actually see some initial state right there as well. That's basically our app. Let's talk about some of these imports and talk about the fact that we are importing CSS in a TypeScript file, which is not supported by the web browser. If you tried to do this in the web browser, it would break. This gets handled by the bundling process. So whenever Vite comes across this file, it uses rollup to say, or esbuild to say, oh, you imported a CSS file? Well, I know what you actually want to do. And behind the scenes, it literally creates a style element and then takes the source code of index.css and puts that into that style element. That's all happening behind the scenes. But all we have to do is import the CSS file, and now we get access to it. If you look at the actual source of the web page, there's going to be a style element up here, and that actually got injected. Yeah, look at this. So you can see that right here, it has an ID, and then those are all the styles of that CSS file. But we didn't have to manually create a style element and put the CSS into it. We literally just import a CSS file, and the build process takes care of that. It basically creates a style element, injects all of those styles for us. Similarly, if you look at the app component, it's bringing in images, right? Importing SVGs is not something supported by ECMAScript modules or like JavaScript modules. But basically it sees this and it knows that it needs to create like a resource or a bundle or potentially load the entire SVG. Let's see how it actually does it. Yeah, you can see that by importing it. So we import React logo, we import Vite logo. We just specify the import there, but behind the scenes, that import got turned into a string. So if we actually look at what got imported here, it's just the path to the file. It's not the actual SVG. And again, all of that is handled by the build process. So if we log this out, you can see it's literally strings. Like it's not actually bringing the whole SVG in. It is just giving us a URL that we can then reference, because whenever we build this, that URL will potentially be different. And then same thing happens right here. So because I'm importing this CSS file, During the build process, it takes all of this, injects it into a style element, and then we can actually get styles for this page. But it's important to note, right? So if you know how CSS works, if there's a style tag on the page and there are CSS inside of it, it applies to the whole page. So this is a little bit deceiving because we're actually importing index here and then app here. At the end of the day, it's all global styles. If you look at actually what gets rendered on the page, both of these are global. So even if I define something over here, it's going to affect the CSS everywhere else in my app. On Tuesday of next week, we're going to talk about other styling methods, and there are better ways to do it than having global CSS. So we're going to talk about that next Tuesday. For now, we're actually just going to be using Pico CSS, so it gets all of our styles by default. But yeah, Muli is asking, can you use Sass? You can, you just have to look at the Vite documentation on how to set it up. So if you go in here, and yeah, just search for SCSS. I don't know if it's actually supported by default. Let's see if it's supported by default. We're going to change that to app.scss, and then let's use Sass for these selectors. So Is that how Sass works? Like, let's kill the process, restart it, and let's see if this breaks. Yeah, so you can see once I start to import this, it's like preprocessor dependency wasn't found. Did you install it? And then at this point, I mean, we're getting off track here, but at this point, I think I can just install Sass. Let's try it. So if I do an npm install of Sass, start it back up, it works. So Vite handles a lot of the stuff under the hood. Typically, you would have to, for other bundlers, you potentially would have to go into the config, add an option for Sass, and add the plugin. In this case, if the Sass dependency exists, Sass just works. So that's pretty cool. And that's like the benefit of Vite. So I got a little sidetracked there. This is the app. This is what's happening. I think the last thing I'll show you is actually what is happening inside of the web browser when this is loaded with Vite. So if you look at the source code, as you can see, it injects a couple of things. So this isn't just directly the HTML file that we defined. This is how we defined it, but then you can see some extra stuff got added, right? So it has this React refresh, it's got the Vite client, and then it links to our file here. Watch what actually gets generated when we click on main.tsx. The source code for this is now JavaScript that the browser can actually understand. So you can see that there's no JSX, right? We are basically, this is plain old JavaScript that can run inside of the web browser, but all of that is kind of handled on the fly. So the moment a file is requested, Vite can take that TSX file, because if I'll remind you, this is what that file looks like, right? This is how we write our code with TypeScript and everything else. And then when it runs in the browser, it needs to be converted into JavaScript that the browser actually understands. So that's what we're seeing when we click on this. But that's basically what's happening. So when we're in development, it can in real time build these files. And so this is in contrast to other build processes like Webpack, where every time a file changes, it needs to rebundle and recompile your entire app. This does things on the fly as they're requested in the browser. And so that's the development process, and that development process is running through ES build. Now, if we actually build this to be something that we want to deploy to production, so if I do npm run build, this uses rollup. And as you can see, it takes all of my code and converts it into 4 files. I have my main index, my React SVG, some CSS, and a JavaScript file. So these 4 files are what we can actually deploy to production, and that gets put into the dist directory. So if I go into dist, actually we can just look at it here. This is the stuff that the web browser is going to understand, right? So there's no more import of like a TSX file. Basically, we import one single JavaScript file that has everything. It has the React library, it has all of our components, everything else. Yeah, so let's look at the assets. So if we look at CSS, this is a minified version of all the CSS in my app. So it took the index.css and the app.css and put it all into this one file with no spaces, as small as possible. And so that's the minification process that's happening behind the scenes. And then if we look at this JavaScript file, this also is, I guess it's a few lines, but this one line right here is 944 characters long. So it basically took all of our codes, all of the React code, and put it into a single bundle for us. And that is actually what gets loaded into the web browser. Also, like the SVG gets loaded here. Nothing special. And the Vite logo too. But this dist folder, this would be the thing that we actually deploy to a website. And I guess let's do that. So I use this tool called Surge, which just lets me deploy static websites. So I want to deploy this. We're going to call this Intro to React Vite example. That puts it on the web, and then now anybody in the world can go to it. But if we look at the source code of the page, we can see it's not, there's no build process now. This is just those static files, and when you visit this page, you're downloading those static files. You're downloading the JavaScript, you're downloading the CSS, and the page is actually rendering out. So you can see my cool example there at that link. But when we build React apps this way, it's that easy to deploy them because they're all just static files. All right. Any comments or questions, concerns, criticisms, all the C's, anything about the layout of this in Vite before we jump into React components and how React components work? Good question, Brian. npm run build used rollup. It's actually hidden even from us, so you can see that it's doing Vite build, but under the hood, Vite build uses rollup. So rollup is for the production build. ES build is for the development server. Can I explain the differences between the two TS configs once more? One is for the dev process and one is for the build process. Yes. So when I am in my terminal right here and I run npm run dev, this is node.js that's running on my computer. This is essentially my development server running locally as I work on the app. And so that spins it up here, and then if I make changes, it has things like auto refresh. So like, let's go in here, let's change the title to be Intro to React, save that, back in the browser, it auto refreshes. Right now I'm in development, and that is handled locally by Node.js. So I have this little program running, it detects file changes, it automatically refreshes the browser. That's the development process, and that's why we need Node.js for that. And that process, potentially behind the scenes, has TypeScript code written that watches for file changes or different things like that. And so that's what this TS config is for. So when I am running the dev server, it's using this TS config behind the scenes. Also, whenever I bundle my app, so let's say we're not in development anymore, we're ready to deploy. If I do npm run build, this build process uses Node.js. It's running on my computer to take all of the modules, put them together into a single file, everything else. All of that is a Node.js process that potentially the code was written with TypeScript to do that. So that's why it needs that separate TS config as well. So those two things are Node.js that's running on my computer. After that, whenever I deploy, it is no longer Node.js is no longer needed, because in the dist folder, these are things that can just run in the web browser. So Node.js is for the build process and the dev server. But after that, you just have static files that you can deploy to the web. To clarify, this is for both the dev server and the build process. This other one is for our code that we write in our React app. So, for instance, inside of here, the fact that I can access document without getting a TypeScript error is because in the TS config, it says, hey, for the TypeScript code I'm writing in my React app, it should get access to DOM, right? If I get rid of these two things, we're actually going to get an error because it's like, hey, document doesn't exist. So it's like, hey, it's not defined. You need to actually include that. But we include it because this is code that's going to be running in the web browser. For the build process, it's not running in the browser. The build process doesn't need access to document. So that's why the node config doesn't have the DOM library. Hopefully that clarified things. I do think if you're newer to this, I guess it can be confusing because there are I guess also a lot of different ways to write a React app. The way that we are writing our React app is basically a replacement for vanilla JavaScript, HTML, and CSS, right? So websites that are running directly in a web browser. That's how we're using React. It's also possible to do things like server-side rendering or static site generation with React using other frameworks. And in that case, Node.js is actually running our React code. But here, Node is not running our React code. The build process is taking a look at this file and generating JavaScript code, but it doesn't actually need to access the document. It just needs to generate the corresponding JavaScript. if that makes sense. Hello again. Thanks again for watching this preview. Again, check out reactroots.com to learn more. I'll see you in the next one.